Only 2 weeks after the first proton injection in 2012, the LHC set yet another record.
So we have collisions at 4 TeV. In all 4 points, things have gone very well. Now we try and optimize them and make sure that we can reproducibly bring the beams into collision. And then we have to spend some time over the next couple of days setting up for normal running. And so stable beams will be some time away because we have to do the setup.
Just before 1 o'clock in the morning on Thursday, April 5, the energy record was repeated with stable beams, a necessary condition for the experiments to start their physics program.
Oh, we're extremely excited about this. In fact, CMS was pushing for increased energy of the machine, and we are very happy that the machine felt safe to go to 8 TeV. We broke records every year. We started at 7 TeV 2 years ago, about the same time. It was great excitement, I remember that, in 2010. And now we're going even higher in energy, which is even more exciting, of course. And although the changes in energy is not so dramatic as we saw 2 years ago, it's only about 15% higher than we ran for the last 2 years. This 15% actually translate in a very big increase in reach for new massive particles. If you want to produce something very massive, you need a lot of energy. And although you increase the energy only by 15%, for some of the particles, the gain in the probability of producing them, or the number of particles you produce, could be as many as factor of 3 or 5 or even 10.
With the increased beam energy, the rate at which Higgs bosons, if they exist, will be produced is increased, but also the rate of some of the major backgrounds are increased, so there are pros and cons.
Extracting data from collisions at 8 tera-electron-volt in the center of mass won't be easy for the LHC experiments.
In the new data, we know that we will have many proton-proton collisions superimposed on the beam crossing. Last year we were having from 15 to 20 at maximum. This year we will go over 30, and this is a big challenge.
The major difficulty is that we are dealing with very advanced detectors which have literally hundreds of millions of channels of electronics, and we have to make sure that the detector is properly working. That's the basics. People in this room, you see, they are actually working on calibrating the detector and understanding it and preparing for the collisions. That's the most important part of our job. Without that, we won't have physics results.
The benefits of operating the experiments ATV are definitely worth the challenges though, as 2012 promises to be a year of discovery for the LHC.
From our calculations and studies, we think that 1 unit of data, 1 inverse femtobarn, is worth about 25 to 30% more at 8 TeV than at 7 TeV. So it's like you're going on a journey. With 8 TeV, you're getting there slightly faster. We will be going that bit faster, so we should get answers a little bit quicker.
Although nobody can predict exactly where this journey is leading, the physics community around the LHC agrees on the primary goal for 2012.
One of the major goals of the experiment, perhaps the major goal for this year, is the Higgs boson. We would like to either discover the Higgs boson if it's there, or close the existence of the standard model Higgs boson.
We may not know what ATV is going to bring, but we can certainly say the 2012 physics season has just started with a grand opening.